we're going to start off with the very basics of geometry. I'm talking about points, lines, and planes. Basically, we use to construct a whole bunch of different shapes. So we're going to start off the most basic thing in geometry, and that is a point. We've done points before. When you hit your pencil and you put it on a piece of paper, that's a point. In reality, that point has no shape. It's got no width. It's got no height. However, as us being human beings, we have a hard time looking at something that doesn't exist as no width or no height. So when I'm making a point, we just make a point. We just have to realize that that really has no shape. We use shape to represent where it is and what it looks like, but in reality it has no real width or height. So we just represent it with a dot. It's just representing it. Now, usually we don't want to just put a whole bunch of points because then you won't know what I'm talking about. So what we're going to do is we're actually going to label this point and we'll use a capital letter. So now if I have a whole bunch of points on a sheet, I could specifically say, hey, we're talking about point A. And sometimes we'll even drop point. We'll just call it A. I'm not a big fan of just calling it A because you'll see we're going to call something else by a capital letter. So you can confuse between the two things. So when I'm talking about point, I'll generally say point A. But it is acceptable to just say I'm talking about A. And we have to know it's point A. All right, that's a point. So we're starting with the most basic thing, just a pencil on a piece of paper. Now we're going to expand that. We're going to put two things, and we're going to expand it in both directions, which leads us to a line. So we start with a point that has no shape, no size, and we extend it in both directions forever, and we get a line. Now, a line has no thickness, but it does go left and right. So even though we can see thickness on here, it really has no thickness. All right, so we start with something that has no shape to something that just has left and right, or up and down, and that is a line. There is exactly one line through any 2 points. So if I draw 2 points on a sheet of paper, picture it. How many lines can you picture going through those 2 dots? One straight line, right? You can't curve it. That's not a line anymore. That's a curve. One line goes through it. So anytime you have 2 points, it's just one line. So we took a point, we stretched it out forever in both directions, and we came up with this line. Now, when I want to specify that line, a lot of times lines will have a lowercase letter attached to them. So if we look at this one, it's kind of hard to tell because it's a little blurry on paper. That is a lowercase l. So if I want to talk about this, I would say something like talk about L, or I might say line L. Once again, I could just say L. Lowercase l, that's what I'm talking about. The other way we can describe it is we can use any 2 points that are on the line. I want to reinforce this idea. A line is actually constructed of an infinite number of points. Even though I'm only pointing out 2 of them, if I wanted to, I could say there's a point here, there's a point here, there's a point here, there's a point here, there's a point here. It's constructed of a whole bunch of points pushed together. So there's an infinite number of points on there. You just need to pick 2 to name it. So I picked these 2 that were on the line, A and B. So we're either going to call it line L, or we're going to call it A, B. But we're going to attach a symbol to that AB. Right over it, we're actually going to draw a line with 2 arrows on it. And that's going to be line AB. To be a line, you have to have arrows on both sides, on the notation and in your picture. If I get rid of one of these arrows, it becomes something called a ray. Yeah?
Does the notation have to be on the top of the...
Yes, it has to be on top. Can't put it underneath. Has to be on top. So if I get rid of one of the arrows, it becomes a ray. If I get rid of both of them, it becomes a segment, which we'll talk about tomorrow. But just so you know, a line has to have arrows on both ends to be a line. Otherwise, it's something else. Just like with the notations, if I lose one of the arrowheads, it becomes something else. You need both arrowheads. Here's the thing. A line goes forever to the left and forever to the right. So if I'm talking about AB, it goes all the way like this. If I talk about BA, it's still the exact same line. So in naming a line, order does not matter. So I could call it line AB, or I could call it BA. Just make sure you put your notation above. Order does not matter. And if I had like 10 points on this line that were labeled, any two of them work. You just need 2 points. In fact, you'd almost never use 3 points because then we're talking about angles, which we'll get into. All right, so we start with a point. I extend it in both directions. Now picture in your head, I'm extending it in both directions, so now we have a line. Now we're going to extend it kind of one more dimension. We're going to take that line, grab it, and shoot it all the way up to the ceiling, and then all the way down. All right, so we started with nothing, basically, just a point. Stretch it in both directions. Now I'm going to go in the other 2 directions to make something called a plane. So a plane extends without ending and has no thickness. It has width, but it doesn't have thickness. So what a plane is, I have a sheet of paper. There's a couple ways to think about a plane. I like to think about like a sheet of paper. But not just any sheet of paper, a sheet of paper that goes forever in that direction, all the way up, all the way down, forever. So this is the biggest sheet of paper you've ever seen in your entire life because it just goes forever. You can't see the end of it. That is a plane. But however, when I turn this sheet of paper, this paper kind of does, but it has no thickness. So if I turn this like this, you wouldn't be able to see it. All right, it's just like a wall that goes forever in every direction. Now, planes can face many directions. I can turn a plane like this. I can have a plane vertical. I can have a horizontal plane. I can have a plane that looks like that. It's just a sheet of paper that goes forever and extends forever. Does that kind of make sense? I think planes are probably the hardest part about this section because we just haven't dealt with those yet. Are we okay with that? Does anyone want me to go over that again? All right, when we're drawing a plane, I do want to note real quick, a point has 1 point. That's what makes it a point. A line is when I have 2 points. A plane is when you have 3 points, but they're not going to be collinear. We'll talk about that in just a second. So basically, if I have AB, I make this line, and I put a dot down here. To get to that dot, I'd have to extend that up and down. So you need 3 points to make a plane. We're going to talk about 4 points, though. A drawing of a plane might look something like this. And you'll see in your notes there's more, or in your homework, that there's more ways to do it. That's not big enough. I want to make it a little bigger. Kind of like a sheet of paper. All right, it's just a flat sheet of paper. Since we can't draw forever, we just have to look at it and say, okay, it must go forever. Kind of like how we had arrows here. Unless you want to draw forever, we just draw a 4-sided figure. All right, usually we don't just draw a square. Usually we draw some kind of depth to it. Because if you look down at the bottom of your sheet, you can see like 2 planes coming into each other. So that's why we kind of put a little angle to it. All right, how would I label this? So one way is you'll actually label all 4 points, A, B, C, D. And we'll call it something like plane A, B, C, D. You could also call it B, C, D, A. You could call it A, D, C, B. But do you see how I'm kind of going around it as I'm labeling it? So if I started here and called it C, I can call it C, D, A, B, or I can call it C, B, A, D. So you need to kind of follow that counterclockwise or clockwise pattern, but it doesn't matter what letter you start out at. The other way we can label these, and this word gets confusing with a point, is sometimes you might put a capital letter inside of it. That S is not a point. That is actually plain S. Points are generally going to be labeled outside like this. If it's inside like this, it's just going to be plain S. So I can put a little capital letter there and call it plain S. Remember I said you can call this A? You can call this S as well. You don't have to specify it's plain or point. Can you see where that can be confusing sometimes? So if I'm writing it, I'm always going to write plain and point to keep it clear in my head. The book doesn't always do that. Worksheets don't always do that. So if I say we're talking about S, you just kind of have to realize what S are they talking about. Are they talking about the plain, or is there a point S somewhere on there? All right, so sometimes it just takes a logical step to know what I'm talking about. All right, so we start with a point, made a line, made a wall, a sheet of paper called a plane. The biggest thing we could talk about is space. Space is exactly as described. It's everything. It's every direction. It contains everything you're going to draw. Typically speaking, your space is going to be a sheet of paper. Anything you write on the sheet of paper is stuff that's within the space of the paper. All right, this represents anywhere you could write on it. All right, we're not going to talk a ton about space. It's not a big, it's just everything that you could write stuff on. Kind of one of those abstract topics of sorts. All right, collinear. We have collinear, non-collinear, coplanar, non-coplanar. So once we understand what co means, then we'll know what non means. Collinear. Lines built right into it. Linear, line. Collinear, co-line. There's a line in there. Points all on the same line. Here's where it gets a little tricky. I don't have to draw the line for you. All right, a quick example of that might be, I'm going to erase that really quick. If I just went like this, and I asked, are all three of those points collinear? You would have to say yes, because if you wanted to, you could draw a line through it. So when you connect the dots, it's a straight line. They are collinear. Don't think because I didn't draw a line, they're not collinear. If you can draw a line through it, they're collinear. The only time so there's only really two ways we can ask this. Either it's collinear or non-collinear. Non-collinear is if you connect the dots, it doesn't make a straight line. So if I connected these dots, we'd have to go boom, boom, boom. I don't think that's a straight line. So those are non-collinear. There isn't one line I can draw through all four of those points. Coplanar. It's got plane in it, so it must deal with planes. Coplanar is points that are all on the same plane. So with coplanar, see this box? This box is made up of 6 planes. All right? I'll try to kind of shade them in, or one of them. So this right here is a plane. That's a plane. Because in my head, I could picture it, it's represented by something that ends, but it really goes on forever up and down. So we have a plane in the front. We have a plane in the back, right behind it. We have a plane on the side, this side, bottom, and top. So we have 6 planes that construct this. Do we all see those planes? Do we all know what I'm talking about? Okay, if we all know what I'm talking about, does someone give me a shot and name 4 points that are coplanar? And coplanar are 4 points that are on the same plane. Yeah. P, Q, R, S. So you're saying if I just focus on one of these planes, all 4 points are on that plane? Yes. You are correct. You're absolutely, because P, Q, R, and S are all on the same plane. Yeah. RSZY is absolutely one. Yeah.
RQXY.
RQSY.
XY.
X, Y. Yes?
X, W, Y, Z.
X, W, Y, Z. Yeah, perfect. I'm going to throw one out there. Q, R, Z, W. I'll say it again. Q, R, Z, W. Is that coplanar? I don't need you to answer. I just want you in your head. Think. Are all those points on a single plane? Well, I just want you to think in your head. Do we have a yes or no in our head? 50-50. I'm going to add to this drawing. So I said Q, R, Z, W, right? That was the ones. I'm going to draw something for you. Are Q, R, Z, W coplanar? They are. It's hidden in there, but if you can draw a plane through it, they're coplanar. What time are we done at? We're done at 12:15. Okay, we got time. It's a tricky one. It's right. At first it was like, no, it can't possibly be coplanar. So don't forget about those. If you need to, draw that in there. Now we're going to talk about non-coplanar. I'm going to let someone give me one, and I'll tell you the easy way to do it afterwards, because I always like to get the shortcut after someone already had to try it and attempt it. Who wants to name 4 points that are not coplanar? You want to take a shot at it? Let's got it.
X, W, P, X.
Did you say PS?
Yeah.
You said S twice, didn't you?
No, P, X, W.
Oh, XW. Okay, I got you then. I thought you said SW. I'm like, well, you can't. All right, X. All right, let's check it out. All right, XW, XW, P, and S. Perfect. That's perfect. And I would say the easy way to do that, and maybe you did this, find 3 points that are on a plane already. So if you look at X, W, P, do you see that plane it's on? There's only one plane that goes through 3 points. So this is the only plane you can draw through it. Now pick something that's not on that plane. So I'm looking at X, W, P. I'm looking at this wall here, right? Pick something that's not on that wall. Pick S. So that's what I'm doing. I'm picturing this is my X. I'm going to pick 3 points from that, and I'll pick one that's not on that. The reason why you probably want to do that is because those diagonals are sometimes hard to see. Like XQ, SZ, those are actually coplanar. But sometimes you're not going to see it right away. So my advice is pick a wall, pick 3 of those, and pick one that's not on that. Good? Feeling okay? Planes are probably the toughest part. Intersection. Have we ever seen 2 lines collide into each other? Yeah, there's a picture right here. And when 2 lines hit each other, intersection is just where do they overlap? There's only one place where they overlap, at that point. So if we look here, when this line intersects this line, they intersect at O. It's where they overlap. So there's an intersection and it's a point. So 2 lines intersect in a point. So this intersects in O. Once again, you could say point O, or you can just say O. I think we've seen it. That's why it makes more sense where 2 lines collide. Do we all agree that it's a point where they collide? Planes are a little different. I have this plane, right? That guy's right here. I got this plane and it collides right here. Is that just one point where they overlap? No, it's actually an entire line because these go forever left and right. So it's actually an entire line. So if we look at that picture that I have here, I have plane M and M. And where they intersect is going to be this line XY. Remember, this line goes forever that direction. and forever this direction. So two planes collide in a line. So these two intersect. And it's going to be a line. So we have to note the line. Let's call it XY or YX. I don't really care. I did not put this on here. But just think about it. I have a line cruising through the universe, and it collides into a plane. What's that intersection?
Point.
It's going to be a point. Because a line is made up of a whole bunch of different points. There's only one overlap. And that's that point right there. That'll actually lead us to the first in-class homework question. First of all, these are common phrases. I'm not really going to go over all of them. They are just, if you're doing the homework and you're confused at what they're asking, you can come up here and see if they're talking about intersection. Are they talking about, is it in this line or not? It's just a whole bunch of kind of common phrases. All right, we're going to go right into this true-false. True-false, 10 questions. So this one says line XY intersects plane M at point O. So we already said that a line intersecting a plane only intersects at a point. So we look at XY. Does it collide with the plane at point O? True. It is true. I do want to talk about that drawing really quick. Do you see these dashed lines? It's because this is 3 dimensions. This plane is coming at us. So if I put my pencil back in the sheet of paper, can you see the other side of my pencil? No. But you want to draw, it still continues. So in this case, it'd be a dashed line. That's that stuff you can't see. So you can't see this, so it's dashed behind it, and then we continue down what you could see. So dashed lines always means it's behind something. When you're drawing like a cube, so if you look down here, it's a rectangular prism, but you can see there's dashed lines. That's all the stuff that's behind that you wouldn't actually be able to see. All right, I don't think we need to do all of these, but let's just continue as far as we can. Plane M intersects XY in more than one point. True or false?
False.
False. Why?
Because it's just going to that one point in the middle.
Yep. Even though it's dashed, we know that's actually through, right? There's only one overlap point. T, O, and R are collinear. T, O, and R collinear. True or false?
False.
It is false. Because if I did that crazy connect the dot, right? We're going T to O. And what was the last one? R. Does that look like a straight line? No. X, O, and Y are collinear. So if I combine those, this can be a straight line. True or false?
True.
True. If I find X, O, and Y, X, O, and Y, well, they're already on a straight line, so that pretty much makes things a lot easier. R, O, S, and W are coplanar. R, O, S, and W are coplanar, so that means I could draw a plane on them. True or false?
False.
False? Let's see. So if I'm talking about R, O, and W, so sometimes what I'm picturing is I'm going, okay, R, O, and W, that's this plane here. Then find that other point, which was W. Oh, I'm sorry. R-O-S. I'm the wrong one. R-O. What did I shade in? Oh, no, R-O-S. Is W on that plane?
Wait. Oh,
Yeah.
yeah. Okay, yeah.
Yep. So that'd be true, right? I think that's the easiest way is pick out 3 of them, picture that plane, and see if that 4 points on that plane.
Okay.
I mean, I think it makes it easier. So that is true, actually. R, S, T, X, those are coplanar. True or false? Yeah.
False.
False? Was that a question?
False.
False. There you go. Even if you're wrong, oh well. So RST, I'm going to kind of picture that plane is here, right? Because that's R, S, and T, because S is here, R is here, T is here. Now I'm going to find X. Well, X can't be on that plane. That plane's way down here. Yeah. So it's false. R, X, O, and Y are coplanar. R, X, O, and Y are coplanar. One person wants to venture this guess. Anyone new want to jump in on this action? No? What do you got?
True.
It is true. It's a little different, right? It's a little different because if I'm looking at R, I'm going to look at R, X, and O. Can we all see R, X, and O? If I combine those into a plane, what I'm actually picturing about is it had to be this plane here. Can we all see that new plane I'm drawing? Now, if I continue that plane down, it's going to combine Y as well. If I drop that down and left and right, do we all see that? So those actually are coplanar because I could draw it. So that is true. Don't just shake your head. Are we all okay with that? That's a complicated thing, that drawing your own plane. It's going to be the hardest part on these, is to draw your own plane. Yes?
Couldn't you then draw a plane on R, S, T, and X?
R, S.
On number 6.
Oh, on number 6?
Yeah.
Yeah.
Oh, so wouldn't it be true then?
Hold on. Let's go. So we're looking at 6.
Yeah.
So let me draw that plane. What plane do you want me to? What 3 things do you want me to use?
R, S, T.
Okay. R, S. Pick 3.
R, S, and X.
R, S, and X. So if I do that, I would draw this plane, right? Do you see how this is a vertical plane? Where is, what am I looking for? R, S, T. Where's T? Up here. Do you see it?
Yeah.
Do you see how it's behind the plane?
Wait, why is it behind?
If you're looking 3-dimensionally, this is behind this wall that I'm drawing.
Oh, the line is?
Yep. Do you see T way back here? That actually is kind of like going off in this direction. And I'm drawing a wall vertically. So that picture is actually, so this is my, see this plane that's going this way? Picture that. This is that red wall I just drew up there. T is actually back behind. Can you kind of picture that this is behind that?
Yeah.
And this wall line goes up and down, left
How
and
do you
right.
know it's behind it though?
How do I know it? Because this goes up and over, and this, see these directional arrows? Those go away from those.
Okay.
So this wouldn't be going, this is the only one going up the wall. These ones are going away in opposite directions of the wall. So basically this wall that I drew goes forever in this direction, up and down, because I drew it along that X there. The other ones go behind and forward of it.
Okay.
Does that make a little more sense?
So in between the red plane and the yellow plane, you mean it's in between those? Between those planes that line is?
These lines,
Yeah.
they actually go through the plane.
Okay.
So if we're picturing, this is 3 dimensions, right? This, I got one coming this way, that way, that way, up and down. So when I drew that one box that went around here, it only had 2 directions. It could go this way, and it went up and down. T goes away from that wall.
Okay. Kind of like that.
On the line, yeah. So that, remember that red box I had?
Yeah.
It's like this. I don't have enough hands. Hold this thing. T is actually way over here.
Oh, okay.
Okay, just like W is actually out here.
Oh,
Can you picture that?
Yeah.
It's
So
behind.
kind of going like that way.
Yep.
Yeah.
All right, awesome. That is all we're going to get through today. I mean, the rest was just kind of actual